Hello everyone and welcome to this video on cache memory. What is a cache memory? What are the mapping techniques available in cache memory, and how to read and write in a cache memory, that would be discussed over here. So coming to the objective or outcome of this lecture, on the completion of these lectures, students would be able to examine the various mapping techniques, read and write operations of cache memory. And coming to the cache memory, so we have seen about different memory concepts in the previous one, like classification of memories, and then we have discussed on the auxiliary memories. Now we'll be discussing on cache memory. So coming to the cache memory is nothing but you would be having a main memory, you would be having a secondary memory, or we can say auxiliary memories. So the memory between a main memory and the CPU is called as a cache memory. And why we are going for the cache memory, or why we are going for the cache, is nothing but suppose every time referring to the main memory, which is a larger memory, is a slow process. Usually to reduce the reduction searching time or opening time, we will be taking the data from the main memory and we'll be putting it in the cache, and then we'll going ahead with the um, any other memory. So this concept is called as um, collecting a data from the main memory and then feeding into the cache memory. From the cache memory to be data. So that is the concept which is taken into consideration of the cache memory. When you go for typically large programs, main program, we say the programs are stored into the memory, and the part a few programs are localized, or it would be on a similar uh, areas of memory. This is localized to areas of memory. This phenomenon where the program are being localized, or we can say at one side, are called as locality reference. And if the active portions of the memory, so this is the locality of reference, or we can say locality of reference. So if the uh, active portions of the program and the data are placed in fast small memory, average memory access time can be reduced. So mean to say every time which have been active portions is nothing but the portions which are being frequently called. If they have been placed in a small memory, the average access time can be reduced, and thereby reducing the total execution time of a program. Such a fast memory is called as a cache memory. When CPU needs to access the memory, cache is maximized. If it is found in the cache memory, it reads from its fast. If it is not going to the main memory, it is a slow process. So if at all a memory is when it is a data is been read from the cache memory, then it is a called as the fast. And coming to the hit ratio and miss ratio, or what is a hit and what is a miss. Suppose if a CPU is referring to some particular data, and if this data is being found in the cache, when it is found in a cache, it is a hit. If it is not found in a cache, then it is referring to the main memory is nothing but what? Usually, miss occurs at referring to the main memory, and hit occurs when you are referring to the cache memory. So, the ratio of number of hits to the total CPU references to the memory. CPU refers to a memory and finds in a cache, it is called as a hit. If it is missed, it is a ratio. So the hit ratio is zero point 0.9 or above, is a very good one. Coming to the mapping techniques. So when you are going for reading a data that is from main memory, and how the data is being collected from the main memory and it is being brought up in the cache. There are three different approaches of the mapping. Number one approach is associative mapping. Number two is direct mapping. Then third one is set associative mapping. How the mapping of data is being crafted in a cache memory that is being shown in the case study. Now going for the associative mapping. In the associative mapping, we will be having, so for example, we have had a memory. Memory addresses are given by 15-bit octal addresses. We use the octal numbers to represent the addresses. So it is 15 bits are being used because the 5 digits of octal digits are there. 5 digits into 3 bits, it is 15-bit address lines. And 12-bit data lines are there. 4 digits are there of octal. So it is 12. So whatever the address you are going to read it up, if you want to take it up on the memory, we are sending it to the argument system. That the address is being mapped with the associated addresses available over here. And if it is small, so this is the example which we did there. Associated memories stores both the address and the content. If CPU places a 15-bit address in the argument register, it searches and finds the matches address. If the match 12-bit address is read from the cache, if no match, main memory is accessed for that one. The address and data is transferred to the cache using any one of the algorithm like firstly it has been shown as a FIFO algorithm. FIFO is nothing but first in, first in, first in. So usually first in, first out algorithm or any least frequently called or least called the data that would be removed. Now coming to the direct mapping. In the direct mapping, this is the direct mapping technique which has been shown over here. This is the CPU has called an 15 address bus. So out of this 15 bits address bus, you would be having 6 bits are being used as a tag bits, 9 bits are used as an index. So now this 9 bits will form a cache memory. Using of 9 bits, you will be having 512 bytes of this. This is the one example I'm taking here. So 512 bytes are 512 into 12 bits data. This 512 cross 12 indicates 512 are the memory addresses and each memory address is storing 12 bits of data. 12 bits of data. Now 32K is nothing but 32K means 3232 cross K is nothing but 1024. So these are the total memory locations. And each memory location is storing 12 bits of data. This is the 12 bits of data. It may be byte or what it is. And now we are considering 12 bits of octal addresses. So here, out of this one, 6 bits are used as an index bits. And out of these 6 bits, the number starts with 00 and it ends with 77. These are tag bits. And index bits would be a set of 9 bits. 9 bits will give you the index address. So one set like 00 is there. That particular 00, it will extend till what? 777. Next 01. 0100 till 77. So you will be having a total addresses of 246 into the cache memories. These many cache memories you can put it up that. So we'll take one index and we'll put it in a this cache memory. So whenever a data is being called, so first the index value is being checked up, and if it is found, or we can say the tag field on the data, both will be taken into consideration. So this would be the concept like it will go for the index addressing, it will start with 00 and it ends with what? 77. So for one particular tag, you will be having one address data associated. So it will check it up the tag field as well as the index. They goes same, then it will take the data and it will feed. If it is not same, then what happens? The same process, what it has been taken into consideration in associated memories, that would be taken. And now we will be going for set associated memories. So when you go for set associative memories, you will be having it would be similar to your um, direct direct mapping, but here two tag fields should be there. For one index, you will be having two tag fields. This is 01 and 02. So once a index has been matched, it will check for both the tag fields associated to one index. Each index will have two mappings. Previously, for one index, one mapping, one tag field. So now, if at all that particular tag is not found, then automatically it need to go for refer to the next one into the main memory. But here, it will check two tags, mostly frequently. This out of the two tags, one of the tags would be matching to the CPU card. So the hit ratio or more number of possibility that the data can be read from the cache. And for all this part, every algorithm will be doing the same process. You will be having, you will be examining the um, main memory if it the data is not read in the cache memory. And one more thing is that the removal of data and adding the new data, it would be from the main cache memory. If it is not found, it would be going for the uh, main memory. That is nothing. Whatever the least used data or first in first out would be taken into consideration. Thank you for watching this video and hope in the next video we'll be discussing on virtual memory.